Okay, testing, testing, 1, 2, 3. Okay, that all looks good. Okay, so like last time, I'll probably just let it run to 10 past in case anybody else is trying to show up. Um, until then, if anybody wishes to follow along, we're using Unity 2020 and up and Visual Studio 2019 and up. Just in case anybody hasn't seen the last video. Seems like there's about a 20 to 30-second delay on the stream, so apologies if I can't get to your questions immediately, but we shall work with what we got. Oh, you did? That's excellent, to kill him. Thank you. See, I already have, according to this, 4 people, which is, 3 people now. Somebody left. 4 people, which is infinitely better than what I had last time, so. Yeah, I kind of thought it happened, and at the same time, I was like, I don't know which group to send that to. At the same time, I'm like, should I send it or not? Because it wasn't an email, but I think nobody reads their emails. So, I mean, I barely read my emails. But this time, hopefully it's better. Oh, thanks. Yeah, I try to make it as informative and not try to be as boring as possible, but still, the systems will only really come into play, like the nav mesh will only be of use next week. This week we'll just be working on the player side of things, so like the health bar, movement, shooting. And next week we'll tie the shooting into something. We'll actually tie the shooting into doing damage to other things. And then probably the fourth and last week will be a like Q&A style session. And I'm thinking I could probably do some things to just try to improve the visuals a bit, because this is meant to really be like an asset pack, but at the same time we can still maybe pretty it up a little bit, because that can never hurt. There we go. Yeah, essentially it will be, it's not really a game, it's individual assets that can be put together to make a concept of a game, and this is mainly how I really enjoy coding and programming, is mainly just making small little things that we can actually combine in the end to make something. So this will have just the level itself and then the player side of things. So when we're done with this small little mini series, you should just be able to take the player component itself and put it into whatever project you're working on, and it will just work. It should just work. It just works. To quote the one true. Yeah, I can release it. I can release it once it's done. It'll have to be once it's done. Next week, still have to get around to programming next week's code. So, but okay, it looks like it's 10 past now. So we'll just go with what we got, and everybody else can rewatch the live stream. Okay, so let's get into it. So where we left off last week, we had this small little world. We had our nav mesh built for it. If I just click on the world itself, I can go to navigation. We have our nav mesh. So this is everything built here. So this week what we're going to get around to doing is we're going to get around to actually creating a player and walking around in the world we created. And it's just like a small refresher of what we covered last week, with just like the usual Unity controls. If you hold down right click in the scene window, you can move the camera around. Whilst you're holding right click, you can do WASD to move the camera. Then what you can do, I need to pause the stream itself. It's really distracting. Okay. So you can use WASD or arrow keys to move around. Oh, not arrow keys. Okay, they changed that. And then to create an object, so we're going to work on creating our player. So we already have an empty game object for our player. And just once again, an empty game object has only a transform, nothing else attached to it. This is the most basic form, like almost like just a shell of something of an object that can run inside Unity's engine. So we have a player. We have our player empty object, and I'm using these more as like, think of them like folders. So like here we have our world, and inside our world we've got all our little objects. And it's going to be really annoying to try to like place things in the world, because if I accidentally click on anything in the world, it's going to select it, and that's just going to get annoying, and I might accidentally move something that I don't want to. So Unity actually has a way of locking items in place, so you can't actually touch them anymore. And to do that, all we have to do is go over to our hierarchy on the left, and then if we hover over this darker square here, you can see there's an eye and there's a little hand. So for the world, if I click the eye, it'll vanish. It's still there, it's just hidden from our scene view. As we can see in the game display, the world is still there. It's just in the scene. Just helps keep the clutter down and keeps everything a little bit more organized. But the other thing we can do is click this little finger, And now, when I try to select something that belongs to the world, I can't actually select it, which is going to make navigating and moving objects a lot easier. Okay, now let's go ahead and create our player. So in our player empty game object, we're going to right click, 3D object, and we're going to create a little capsule. And pretty much this is how every game that I know of has some version of this. Is like your first person character is just a little capsule. We're going to start out making the first person character because the third person character is to create a third person character is so ridiculously easy, it's funny. Okay, so we have our capsule. We can rename this, right click, rename, and we can rename this to player model. LEL, I don't know, I can never remember. I think it's mod L. Spelling is not my strong point. So yeah, so now we have our player model. And inside here we can put anything that's relevant. So like if instead of this little capsule that we had for our game, if you had a model of a person or a character or an item that you wanted to take the place of it, how the system will work is you can just go ahead and delete that model and put in your one, and it will work fine. Because it should all be interchangeable. The data side of the program should be completely separated, or as separated as much as possible from the actual physical graphical layer, which means we can swap things out, change things. We can even maybe later down the line open it up to modding support if you wanted to with that kind of system, which is why I particularly like that style of coding. Our player is a little bit in the ground now, so our player has a height of 2 in Unity, so we're just going to bump his model up by 1. We're moving the model up and not the container itself, because if we move the container, it might cause a few problems later down the line with us trying to calculate some things. So that's why we're just moving the model itself up by 1 on the y-axis and not the container itself. So if I move this up now, you can see our guy is floating. But when we come to do gravity and stuff like that, gravity really wants our container itself to be at 0. One sec. Dry throat. Okay, we have our player model. Our player model needs a camera in his eyeballs. So what we can just do is we could simply just come over here to our main camera. This is a camera that's tagged as main. And this is the camera required for our game view here. Without this camera, our game view camera doesn't work. So we're going to just drag this up to where we feel roughly comfortable. And we can also fine tune it here. So like 1.5 is about there. And we can see the little like graphical display of how what our character is going to see, just to like help guide us a little bit. So like I usually do like 1.5 for our main character. Now, the problem we have right now is the main character isn't attached to our player container. So if the player goes ahead and moves, the camera is going to get left behind. So we need to drag the camera into the player so that everything will move. It's all relative. So now if I move the player around, the camera goes with him. Okay. I think, oh yes, and then the last model we have to create is a weapon for the player to use. So we're going to go right click the player container again, 3D model, and we're just going to create a simple cube, just nothing too fancy. Nothing too fancy, it's a little bit big at the moment, so we can come up here to the top left with all our tools. We can click the scale tool, and we can just squish it in a bit, make it a little bit smaller. Ones are usually a lot taller than they are wider. Okay, and we can move this forward. So once you get like the hang of all the tools, you can move it. You can get quite fast at this. So right now I'm just moving everything into position. Just rather quickly trying to just speed through. I did cover a lot of it last week. Everything looks a little bit bland for all our stuff, so we're just going to give things a quick touch of color. One quick thing though, if I move the weapon here, you can see over here on the game view, it's clipping slightly through the camera, so you can see through the weapon model itself. So what we can simply do is we can go to our camera, and if we go down to clipping planes, so this is how far the camera can see and or how short the camera can see. Outside of these ranges, the camera just will not render the item at all. So we're just going to drag this back a little bit, and you can see now the amount of the model showing is getting closer to me, and I can drag it back a bit more to about 1. And now we can see the whole model. Just move this back to where it was. Just try to find like a position you would expect to see it. Okay. That seems good. We need to create just a few materials just to help define it. So if we go over to our projects directory, this is where all of our main files are kept for our program. Everything in here will get compiled when we build the game, so keep everything here. We need into our assets window, we can open our materials. Here there's I created a player folder, I forgot to delete that, and then I have a material here for a gun. Just a gun material, and like last week we can just drag it straight on, and now our gun has been made black. We can also change the color to whatever we want in the color wheel. We also I can also make a material for the player, but not really needed because we're not really going to be seeing him at the moment. And then that's that done. Okay, so now that we have everything set up, let's get on to actually creating some of the code that we're going to be needing for our player and player movement. So let's first go over how our camera system is going to work. Before we can start programming, we need to first understand how our camera is going to work itself. Yeah, just so we can set up. So like with everything in real life, you need a camera rig, which involves a tripod, a few pivots and stuff, so you can maneuver the camera around where you want it to be. So for our camera right now, our camera is just fixed inside our character's head. It can't really move that realistically too well. And the other important thing is we can't manipulate other things. So the most important thing, if I rotate the camera, you can see the gun doesn't come with it. So we're gonna just set up a quick little pivot system so that the gun does rotate with the camera itself. So in our player, we can right click, create a new empty, and we can call this camx pivot. Pivot, and we can drag the camera and the cube. Oh, I forgot to rename the cube. Pivot, main camera are both now on the camx pivot. The cube we can rename to gun, just to keep everything a little bit easy to understand and easy to follow. Now that it's all attached, we can now rotate our gun up and down, left and right, and it comes with us, which is good. Okay, now that's everything that we need. So let's get into some of the coding. So if we go back into our assets folder, so like our main directory, we've got our materials and scenes. We right click and we create a new folder, and we can call these scripts. So all of our scripts for our game are going to be held in here. I'm a little bit crazy with the organization, so I'm going to also create two more scripts, one called global and one called player. Inside our global folder will be every script related to pretty much almost everything that happens across the world, across our game world. So anything from enemy spawning to our shops, any form of data like that, which needs to be accessed from a lot of different places, will go in global or used across folders. So I'll explain more about that in a sec. And then we have our player folder, and these are scripts specifically dedicated that only the player will be accessing. Only the player, nobody else should be touching scripts that are kept in the player on the player folder. And this is just another way of helping keep things separate. So it's like, hey, I just need the player code, goes in, grabs the player folder, and moves it to a different project. Or I need like the zombie code, so just grabs the zombie folder. So inside global, we're just going to start off really easy. We're going to right click, create a new C# script, and we're going to call this stats. So now we've made our first C# script, and it's here. So we can double click to open it. There you go. So now we have it opened in, and like I said, I'm using Visual Studio 2019. You can use code. Unity's perfectly fine with you using code. In fact, you can change it in your project settings. Edit, project settings, editors. I believe it's somewhere here. Editor. I will have to find it again. I had it open a minute ago, but inside your project settings, you can change exactly which editor you want to use. So you can use VS Code. You can also use Visual Studio. You can use other things like Eclipse. I think you can use Eclipse. I'm not entirely sure if it still supports it because I believe Unity dropped support for Java. Okay, so I think that should be big enough for stream. You guys let me know in chat if the text is big enough on the, if the chat in the window is big enough for you. If not, I can increase it. Okay, so we have our first script. We have the script is inheriting from a mono behavior, which we don't really want right now because we are just going to create a standard object. So we can get rid of those. We can just get rid of everything in the script. So it's just a purely blank script. And the reason why we're doing it this way is because the goal is to have both the player and the zombies both use the same code so we can recycle it. Can we make it bigger? Sure, no problem. Okay, let me know if that's enough. So the goal of this script is to be used to prevent code duplication, to be used from both the player side and the zombie side of things. We have our libraries up here, just ignore this for now. We have just our systems collection, Unity engine. This is all things that we just need to, I think the delay is a bit too long. I think I can change that, but unfortunately if I change that, the quality does drop quite a bit. It's good? Okay. Yeah, I'm not too familiar with how the YouTube Studio system works. Okay, so, but this is big enough for you guys. Just let me know if it's big enough. So we're going to first go about creating. I think we can actually get rid of the Unity engine, but we'll just leave that for now. It's just the classic programmer. It's like, I think this was okay to remove, but let's keep it just for now, just in case. Let's get into it now. So the cool thing that we need. So let's first discuss what we need in our stat system. What is our players and our zombies both going to need in order to function? So we're going to need a health. We're going to need our health system, the movement speed, and then the attack speed and the attack damage. The attack damage for both the zombies and the players. It's big enough. Excellent. Excellent. Yeah, so the attack speed and attack damage, that is mainly what we're going to need. So those are our primary things. So we're just going to store them here. So we can do a public float, and I'll tell you why we're doing it as a public in a minute. Float, and we're going to do health, our health, and then we can do a public float max health. Because how our health bar is going to work is we're going to have our max health, which is as high as it can go, quite self-explanatory, and then our health will be our current health, and we can use that to get a percentage, which we're going to need for our health bar later. Then we're going to need a public float again for our move speed, a public float for our attack speed. I hope the keyboard isn't making you guys deaf. Attack speed, speed, and then we can do our attack damage. Okay, so now we have our health, move speed, attack damage, health, max health, move speed, attack damage. So we still want to be able to access these, but we don't like them being public. Now, what you normally have to do in other programming languages is you'd have to go in and you would have to make your own separate classes for basically for like a getters and setters. So you can just make sure that only the specific programs can access it. And in doing it that way, you can make these publics private, because you will have a public getter which can't be changed. Yes, these are in, so our stats system is in our global folder, yes. Because they're going to be accessed by both the zombie and our player at the same time. Essentially, this is an object which will allow us to create stats for the different players. So if we want different zombies, we could just change each zombie to have a different stat system, to have a different stat values, which allows us to very quickly make different variants on zombies. Or if we want to change the player health, something when like final tweaking later. So we want them to be public, but we also we don't like the code mess that comes with creating getters and setters. So what you can do in C# is you can tell it specifically that it's a get and a protected set. So what this means is anybody can get it. It basically works like a public variable. But it's a protected set, which basically means when it comes to setting, it works pretty much like a private. So only the script can change the value of health. And we can just set that to all of them. Okay, now everything is essentially a protected public. Basically think of it, yeah, it's a protected public variable. Anybody can read it, but not only the main script can change it. Okay, next we will need to create the class itself, the class object. So we're going to just, public stats, not stack, stat. And we are going to pass in our starting values. So we're going to pass in a max health, a float. We don't need to pass in a health because at the beginning our health will be equal to our max health. So next we're going to do is move speed. And move speed we're actually going to have as a default value of 10, just to like make, so we don't have to keep setting it over and over again, because most of the things will be moving at a speed of 10 anyway. We're going to do a float attack speed, which we're going to default to just 1. The reason why I'm putting Fs here is these are float values, so I'm just putting Fs, which tells the compiler that they are floating point values. Okay, next we have our attack damage as well. Attack damage, which will just be 10F as well. We can tweak these values later. These can be overwritten, which is really nice, but for now we're just having them as default values. Okay, and then we're just going to set up our standard usual imports. So our health is equal to health. We can actually do something quite fun. So health equals max health, which is also equal to max health. Now this will make sure that all these three, health and max health, are the same as health. The health we received. Then we're going to do move speed. I can spell move speed, and the same for attack damage. Attack damage, and that's our stats object created. We can create one more thing that we're going to need later, but we're probably not going to need to use this for a little bit. We can do a public void, so there's no return. Take damage. And then we're going to have a float of amount. And then this... And then this script will just be called whenever we need to damage either the zombies or the players, because this is going to be used by both. So we're going to do health minus equals amount. Just a really easy way. It's the equivalent of doing health equals health minus amount. They're both the same thing, it's just a lot quicker to write the first one, and a lot cleaner as well. And then what we can do is we can just clamp this to 0. So we say like if health is less than 0, then what we can do is we can just set health to 0. This is just so we can avoid having any enemies running around with negative health, which could cause problems with our code if we are specifically looking for a 0 value. Okay, so that stat's now finished. We're going to go back into our script folder and let's get to work on the player. Let's get to work on the player himself. So right click, create new script, and we're going to do Playercontroller. And we're going to open this up in VS Code. Yes. Go. And this time we are going to be working in the Unity engine itself, so we're going to need the mono behavior. So this is how we talk. If something in Unity, if something in our code derives from mono behavior, it means that it's required. It's how we talk to the actual game engine itself. This is when we start using Unity's own custom code and custom objects. Not too complicated. It's pretty similar to how regular C works. In fact, yeah, it is just regular C. C sharp. So let's keep going. So first, what we want to do is we want to import our stats itself. So we can make a comment here so we know what we're doing. Player stats. And this is everything that'll go for player stats. So the usual way I organize things is I like to have publics on top, privates on the bottom, just so it's really easy to quickly grasp what I need. So we're going to have a public stats, our stats object that we made, and then we can do player stats, and we can also make this a get protected set. Get protected set. And then what we can do is we want to set the starting health of our player. And to do that, there we go. So we want to set the starting health of our player. So we can do we could do the usual thing, make it public again, but we don't really need other parts of our code shouldn't really need to access it. So what we're going to do is we're going to make this private, float, and then health. And then this is the health of our player, which we're just going to set to 100F for like 100% or just 100 points. But now the problem is that in Unity, we have now no way of setting that value, and we want to be able to change some of that. Signed value but never used. Okay, we can ignore that. So we want to be able to change the health value on the fly to do some testing and things like that, but we don't want to make it public. So we can do something which is really neat, which is we can make the field a serialized field. Oh wait, hang on. Let me first show you what it looks like if we don't do that. Just so I can give you an example of how it looks in the engine itself. I think I'm talking a little too fast. So if we go to our player, we have our player script component here. And this is on the actual empty object of our player itself. So we can take our player, click and drag, and just drop it straight into the inspector on the right. And now we have assigned our player code, our player script, to our player itself. Now the script can reference our object, and this is how we make the connection between our script and the physical in-game world itself, like in the engine. If we don't attach it, then there's no way for us. There are ways, but no easy way for us to physically find our player itself. We can do other things like that, but that's a little bit complicated, and we can talk about it later. Okay, so now we have our script attached to the player, and you can see now there is no, so you see how we have transform, we've got position, rotate, scale, but our script, we've got nothing. We just have script, which is the name of the script, and this is grayed out because we can't change it, because that would be bad. So what we're going to do is to fix that, we can go back into our code and we can make this a serialized field. And in doing that, this is how we can actually add Unity editor modifications. So we can also do like a range on it as well. So we can, if we wanted to, we could say between 10 and 100, like that. And then we can tell the editor that it's a float value by just using Fs. And now what this will do is this private variable of our health will now appear in the editor as a slider that we can essentially move back and forth. So if you see it, just let it recompile. And now we have our health bar here. Our actual starting health for our guy, and you can see I can move it around. and it's clamped between 10 and 100. Or if I don't need that, if I just want to specifically set values, I can remove the range, go back into Unity, and now it's gone back to a standard text field, so I can make it 1,000 or just 100. And now we are successfully communicating with the engine itself, which is really good. And it's just that easy, which is why I love it so much. Okay, let's go back into it. So that's all our player stats set up. And now what we can do is we can define the stats itself. So we can tell our stat object what our player's health is supposed to be. So we can do a private void. Now Unity has orders of execution, and they are different. They are execute at different times. So when I have awake here, so if I type awake here, this will pretty much be the first thing that happens in the Unity engine itself. So, oh, that's the wrong one. That's our dev stream. There it is. There we go. So this is the Unity documentation. This is a very good source of reference for everything that's up to date with the engine. It even tells you that if you're trying to use something that has been depreciated or they don't use it anymore, it'll actually give you suggestions on the newer versions of it. So really good source of information if you're trying to learn specifically how to work with mono behavior. But the orders of operation inside Unity, so you can see we have awake, on enable, reset, start, on awake, reset, start. So the two that we're focusing on at the moment is the difference between awake and start. And you can see awake happens on initialization, and they're both initialization, but awake is the first thing that happens. So as soon as we click in Unity, as soon as we click this play button and we start our game, awake gets called. However, start happens a little bit later, so it waits for it waits for the objects to finish initializing, some of the resources to load and stuff like that, and then start will get ran. But awake literally tries to make it to the front of the gate as fast as it can. So that's why we're going to set awake, because we are going to be defining the player's stats themselves. And we're going to have other components that'll be running in start, or maybe later, like fixed update or on trigger. No. So how it works is Unity, when you click this play button at the top, it sort of does like a mini compile in a way. It doesn't fully build the application, but this is the same as just running it. And then through mono behavior itself, through the interactions with mono behavior. So if I go to definition and see if this works. So we can see here, so here's mono behavior. Yes, that worked instantly because it is... What did I do? Oh, I closed the wrong one. Okay, think of it like this. Oh, right, so it worked instantly because I'm working in the editor itself, and this has essentially overridden my values. So even though I've told this to be 100 here, or when I was using that slider, if I were to go back into the player controller, turn you up, please. There we go. If I were to go back into the player controller and I were to change this health from 100 to 10, and then I go back into Unity. Now watch it work, because it's... See, I went back into Unity, but it's still at 100. Because the editor has taken that serialized field, and it's stored that value internally. Think of it like that. So it's now disconnected from what I have typed in my code. And this has caused a lot of problems in the past with me with some errors. Because I'm like, oh, why isn't this value changing? It's like, oh, because Unity has their own value internally. And then this value will only get re-updated the next time I open Unity. Because that's the next time when the editor actually compiles. But once I go in game, it'll just read off of this value that's here. It completely ignores what value I've typed in. So I could leave it at 0 and it wouldn't really matter. Hope that helps answer your question. So you can see the value here is 10, but it's still 100 in the editor. The editor didn't change to 10. because Unity has stolen that value with the serialized field. Okay, back to it. We have the serialized field. Oh, I forgot to save it, so I need to do private void awake. So we're going to do the awake first, and once again, the reason why we're doing that is because other things are going to rely on our player stat value being initialized. So no problem, Akila, and I hope you're having fun. So we're going to make our player stat, so we can do player stat equals new stats. And since we have default values for all of our other stats, the only stat we really need to give it is our health. Because all of our other values, you can see if I put a comma here, they're all default. So I don't need to actually change that, and that helps keep the code like nice and clean, and I only need to override it when it's absolutely necessary. Cool. Next, what we're going to do is we are going to now create our update, and this is the main loop inside the Unity engine. So update triggers every frame. So every single frame, so if you have 60 frames per second, then that means update will get triggered 60 times a second. So you don't really want to keep anything physics-based here. So any like physical calculations and stuff, you don't really want to do it, because if your frame rate suddenly drops to 30, all of a sudden all your physics are in slow motion. Or if it suddenly jumps to 120, all your physics is on 2 times speed. And players can abuse that by changing graphical settings and stuff. There have been a few games in the past where speedrunners can actually do that. But anyway, we're getting sidetracked. So what we're going to want to do is we want to mainly work on our mouse component itself. So our ability to look around the world. So we'll just first build it in here, and then later on we can move it out. Generally, I try to keep your update loop as clean as possible, and mainly just branch out into other methods itself immediately. Because, yeah, just not much has to happen here. So we are going to just work on it in the meantime. So first what we need to do is we need to get our mouse's information. So for that, we're going to be using a vector2, and this is something that is inside of Unity. It's the Unity engine itself. And the vector2 is just like a simple object that stores two floating values. So we're going to call this mouse. Mouse input equals new vector2. Same way we declared our stats themselves. And then for what we can do is we can do input dot get axes. We can get our axes, and so this is the cool thing, and this is where working with a game engine itself is very important and just helpful and can save you a lot of time. I can just type here mouse X as one of the inputs, and then I can also just copy this section of code. And I can change that to mouse Y. So what this is doing is the Unity engine itself. So you can see here, once again, this is Unity engine. This is from the Unity engine package. It's going to go in and do all the complicated stuff on how to communicate with your mouse input into your Windows computer or into your Mac or anything like that. It'll just do that and then we can just grab that information straight away by using this one tiny small line of code. And now what this vector2 will be holding is the mouse's position in the mouse's movement in the world. So if I move it to the right, it's going to get +1 on the x-axis. If I move it up, it's going to go +1 on the y-axis. So that's what's stored inside this movement now as well. Cool. Now we actually need to translate that data into the world itself. So we are going to go back, and remember in Unity we created this camera pivot. And we're going to use that now, so we're going to go down here. So this is for the camera. Player camera movement. Just to keep our variables all separated and nice and neat. We're going to make, this is going to be a serialized field. If I can hit the right keys. Serialized field of a private transform. Private transform cam x pivot. Or is it pivot? Pivot. pivot, whatever. Don't care. Now we go back, we can see that it's going to be created on the player, so now we have a new one. We can just take our objects from the hierarchy, we can click and drag the camera pivot and now we have reference, the camera pivot variable is now referencing this object in the hierarchy, and we can move on. Really, really easy, really simple. Then what we're going to need to do is we are going to need to also create a private. I'm hitting all the wrong keys today. Another private float mouse sensitivity. And this is going to be how fast our mouse can move, because since we're going to be working with time.delta time, and just the straight value is between 0 and 1, so we're going to need to multiply it to actually get some kind of movement out of it. Next, we're going to do a private float camera pitch. And this value will be how high the camera is looking, up or down. So for now, the camera pitch is just going to be 0. And that's all the variables we need to get the camera working. Now we can go back down here. Now let's actually get it. So where am I? The camera pitch, so pitching up and down now, is we need to add to it, because as I move the mouse cursor up the screen, this value is going to be increasing from 0 to 1, as depending on the speed. So the faster I move it, the faster this value increases. So if I move it really slowly, it's going to be like 0.02. If I move it really fast, it's going to be about 1. So we can add this value to our camera pitch. And I'll do it this way first, and we'll have a problem, and then I'll show you how to fix that problem in a very easy way. Mouse input dot y. So this is us just referencing the y component, which is this over here, the y component in our vector2. And then what we're going to do is we are going to then multiply this by the mouse sensitivity. And then finally, what we need to do is we need to make sure the camera, we need to make sure that this value is limited between two ranges, because if we don't want the character's head to be able to look up high enough that it spins all the way around, and he can look back at the floor again by looking up. That's really weird in the game. Some games allow it, but most don't. So what we can do is we can use camera pitch equals math f dot clamp. And then we enter the value we want to clamp, so that's the camera pitch. We set the lower value, so that's 90F, and plus 90. So now the camera can't look any higher or lower than 90 degrees. And then finally, we want to translate this into the world itself, so that we can actually see this all come together and move. So to do that, we're going to do camx pivot dot local Euler angles equals vector, and then this is another version of the vector2 where it's a vector3 dot right. And what a vector3 dot right is, let me just finish this. So we do the camera pitch. So vector3 looks something like this, 0, 0, 0, just by default. Okay, this is a vector3 dot 0. A vector3 dot right is, oh, this is fun. Vector3 dot right is this. So we have 1 on the x and 0 on the y and 0 on the z. Then you've got vector3 dot left, dot up, dot down, dot back, dot forward. And it's just all variations of this. I think if I hover, there we go. So you can see vector3 dot right is just a quicker way of writing new vector3 of 1, 0, 0. And then I can also do vector3 dot up. It's just an example to show you. And in the text, you can see it's 0, 1, 0. So just quicker ways of writing it. Helps keep code clean. Okay, so what this will allow us to do now is move the camera up and down, as long as everything goes all right. So we're going to click OK. And now I can move the camera, but you're noticing something weird. In fact, yes, we are noticing something weird. What is... That is very... Oh, hang on. I think I did that the wrong. Camera Y, mouse sensitivity. Always fun doing it live. What did I do wrong? Camera. That's fine, that's fine, that's fine. Unless maybe... No, local Euler is fine. That's weird. Why are you doing that? Stop it. The pivot is like off. Okay, well, that is working. I just don't know why the pivot is really weird, but let's not waste too much time on it. Let's get the rest of this working. Seems more like suicide mission. Yeah, pretty much. Pretty much. You can just aim back and shoot yourself in the head. That's really weird. Why do you do stuff when I'm trying to teach? That's fine. Oh, this is exactly what I was saying to you guys in the last video. Be very careful of your transform dot positions, because the camera pivot itself is on the floor, because the camera pivot's position is 0, 0, 0, but our camera position, and as such the other position of the gun, has been lifted and moved. So we need to just quickly reset these. And then reset this. Okay, now what we could do is we can take the camera pivot and move the pivot itself to 1.5. And then just reposition our gun. There we go. So now it's working. Cool. Slight problem, but you see, it's the smallest things that get you, and even when I'm warning you guys about it, it still happens to me. So there's one slight problem with this. If I move the mouse down, I look up. If I move the mouse up, I look down. It's inverted controls. And the reason why is because when I'm moving the mouse up, I'm doing a positive value. However, to rotate if I go to the rotation on the x-axis and I rotate it in the negative, I'm going up. But when I'm moving up, I'm applying a positive value. So I'm telling the game I want to rotate down, if that makes sense. So up on the mouse is positive, down is negative, but the camera is actually inverted to that. So the way we get around that and fix that is instead of doing plus equals, we just do minus equals. Then we run it. And now you can see we can look up and down with our mouse. Okay, let's pick up the pace just a little bit because we've already been here for an hour. Let's get to work on let's finish this up and get the rotation. So when we rotate our player now, we don't want to just rotate the camera pivot. We want to rotate the entire player model itself. Yep, all you need to do is flip it. So we don't want to be rotating the camera pivot, because the problem is we rotate the camera pivot this way. The problem is our player is still pointing this way. And that can lead to, that's the player model. Our main player is still pointing this way. So it's more like mech controls in that way. It's more like tank controls, where you can look in one direction, but forward is always forward in relation to the body. But we don't want that kind of movement. That's not the style of movement game we're going for. So instead of rotating the camera pivot, we're going to rotate the actual whole body itself, and that's just really, really easy. So let's just put a comment in, rotate player, and then this one here is rotate camera pivot. Oh, okay. Whoops. Okay. I believe that would have reset Unity. So yeah, you can see I changed the name of that, so it reset that. So we're just going to fix that. Oh, and I completely... What did I spell there? Anyway, it doesn't matter. Does not matter. Code doesn't care how poorly you spell. Okay, so to rotate the player itself, really easy. We have our transform already because we're attached to the player themselves, so we can just do transform.rotate, not rotation, rotate. Rotation and rotate are two different things, so just don't get those mixed up. Vector3.up because we're working in the vertical now. Instead of working on the x-axis, now we're working on the y-axis itself. Then what we want to do is we want to multiply this by the mouse input.x, and then finally multiply that by mouse sensitivity. And then that's that. Now we should be able to look left, right, up, down. There you go. So now we can look around and we can change the mouse sensitivity in our code. Whoa, we're just done with that. All good. I hope I have enough time for everything. But it'll be really nice if we can move around. So since we're done with this code, we can actually take this out of our update just to try to keep it clean. We can do private void mouse look. And then we can simply just put it back in update. And hide it. All gone. Was never there. Don't worry about it. I'll leave it open. No, I'll keep it closed just in case you guys want to keep things. So now we're working with the movement system of our character. Once again, really easy, simple way. We're going to just re-interact with the game engine itself. We're going to do a vector2. We're going to do a vector2 input direction. So how this is going to work is we're just going to store what keys are currently being pressed, or the value the engine itself is returning because of that. So we're just going to do input dot get axes, and we're going to be doing get axes raw. Notice how before we did get axes, this time we're going to be doing get axes raw. Get axes uses a in Unity, get axes has a built-in smooth factor, so it slowly ramps up and ramps down, which makes mouse movement really good because it's nice and smooth. It's not really snappy. But for our movement system, we want something a bit more accurate. So this is something like if you want to do a platform or anything, you'd use get axes raw, which is just straight. As soon as I press forward, it reports a 1. It doesn't report 0, 0.2, 0.3, 0.4, just straight away a value of 1. And for that, as long as I can spell this right, so the axes we're going to be getting is our horizontal axes, and then we're going to do that again. So input.get axes raw, and I need to spell this correctly. Spelling is important, and capital letters are important. It is case sensitive. Where you can find this information out in the Unity engine, they've moved it in the new version, which took me a little while to find it. But if you go edit, project settings, and then you go to, now you see I had it, and then now it's gone. Input manager in the project settings window. This is all the inputs the Unity engine can give you by default, and you can add more. So right now we've got 18 inputs, but if I wanted to, I could change this to 20. And now you can see I've got new inputs, and then I can define here what I want the engine itself to tell me about those inputs. So I can change them to joystick buttons if I wanted to, so like controller, an Xbox controller, flight stick, something like that. I can specifically bind them, but I can also add alternate. So you can see here, here's our horizontal and here's our vertical. And you can see the horizontal and vertical work with left and right, or A and D, which is important because now, instead of saying like get key down A, get key down D, or get key up, or anything like that, now just with one small line of code, I am working with both left and right on the arrow keys, and A and D, or up and down, same vice versa. So just really easy, keep everything nice and compact. Then what we're going to need is input direction. We need to normalize these values. And then this is the problem where if ever you try to do if you ever try to do the square root of a triangle, no, of a square, from the two different angles, like so, if we have up and down will give us a value of 1, but if we do up and left at the same time, it will give us a value, a return value of 1.4. Now that means the player will walk faster going diagonally, which we don't want. We want it to all be even at the same time. So we need to normalize this value, this input direction. So we do input dot normalize, and then this will now limit it to a value between 0 and 1. It can't exceed 1, so it's all even, everything like that. Then finally, we need to do the actual movement itself. So we need to take this input data that we've been getting and apply it to the engine. So we do vector3 of a velocity. So now this will be a way of the engine like carrying over so our input values into physical movement in the world. And then to do that, we're going to do a little bit of math because, yeah, just a little bit of tiny math. So what we're going to do is we're going to do transform.forward. Now this is forward of the player itself. So no matter what the rotation of the player is, forward is always local to the player. So it'll always be straightforward. So it means that when you press W, it'll always go the direction you're looking. Then what we're going to do is we're going to times it by input direction.y, which is our vertical. So our WS, or forward and backwards. And then what we're going to do is we're going to add to that our left and right movement. So transform.right multiplied by input direction.x. And then finally, this whole overall thing, we need to take all of this and we need to multiply by our player's movement speed. Now our player's movement speed is coming from our stat window. So we're going to need to get this value from our stats. And we know up here we defined our stats as player stats dot movement speed. And this is the cool thing about using these getters and setters, is that we can. Cool. So now that's our player movement system set up and running. Oh, right. Last thing we have to do is we need a character controller, which is how Unity knows what a character is and how to move them around in the world. So if we click on our player, we can click add component at the bottom here, and we can type character, and we can see we have character controller. Now this is going to create its own little collision box for the character itself, so we just need to set that back to 1. So it's all in line with our object's collision box. In fact, if you really wanted to be optimal, you could take the object itself and disable the capsule collider. But you can leave it on, leave it off, same thing. Then what we need is we need a reference to that. We'll need a reference to that character controller so we can actually feed now our velocity data into it. And this is why we need to calculate velocity, as our character controller requires that as an input. So we're going to need to do, once again, this is for movement. This is for the movement itself. So we can do, although we can make this another one. So for player. And then what we can do is we can do a private character controller. And then when we go to our awake state, one of the other things we can also do is we can grab a reference to that. So you don't always have to go into Unity and click and drag references all over the place, because you notice I made that character controller component private. This reference here is private. But we can get a reference to it in code by just simply using another Unity engine command, which is get component. So we can do character controller equals get component, and you can see we have get component in children, get components, and this will, the only thing you have to keep in mind, be aware of when using this is a get component will return the first value it finds. So if I use get component and I have 3 character controllers, it'll always return the first character controller. If I wanted to find all 3 of them, I have to use get components. And then we have to tell it the component type it's looking for, which is character controller. And now we have a reference to the character controller on our script, on our player object. And then what we can do is we can go down here and type in character controller dot move. And the input for the move is our velocity. And then this is a sort of physics-based calculation, so we need to make it we need to give it a reference to the frame rate so that it all happens at the same time, so we don't have people on different machines moving at different rates. So we do time.delta time. Pretty just easy, common way of doing it. And now we should be able to move around in the world. So I can look around, I can move now in the world. I can wave at the camera, hello. And if I expand the game view itself to full size, we can walk around. But there's one slight problem. I'm going to walk up this ramp, and now I'm going to walk off. And I'm levitating. Because we haven't programmed any like gravity into the game. I can just float around here, I can float up here, and essentially, yeah, we haven't programmed any form of gravity. So let's go ahead and just get that into the game really quickly. So inside our movement code, we can go in between the velocity, because we'll need to add this to it. We'll need to add all this together. We can go up here, because if we want to tinker around with the gravity itself at a later date, like maybe you have like your game is like set in space and you want like half gravity and stuff, so we can make this a serialized field as well. Let's just put a comment in. Gravity. We can make this a serialized field just to give the player a bit of control. Serialized field. Oh, my chat just crashed. Oh no, we're good. So we're going to make it a serialized field. We can have it be private, so that nothing can mess with the gravity in our world. Gravity. And I found -15 is pretty good as a starting value. Unity's engine isn't particularly one-to-one with real world, so we're not going to use 9.81 or something like that. And then we need to keep track of our vertical velocity, which we need it to reset to 0 if we're touching the ground. So we can't actually keep it inside our update script. We need it to be like a bit more protected than that. So we're going to have it a float vertical Y. Actually, no, not vertical Y. What's a good name for it? Velocity. Velocity on the Y-axis. And we're just going to set that by default to 0. Now, Unity has a nice built-in way of telling if the player, if I go over here. So right now you can see the player is on the ground. And Unity has a really nice built-in way of telling if the player is actually touching the ground or not. So what we can do is it's called isGrounded. So if our character controller dot is grounded, and this returns true or false, we can set the velocity, the vertical velocity of y is equal to 0. Then what we want to do is, if it's not, we want the vertical velocity to be plus equals, because remember we're working with a negative gravity, so we want to be adding that, because if we do it in reverse, then our player will just float up off, basically like Charlie in the Chocolate Factory, that scene from Charlie in the Chocolate Factory. Gravity, our gravity value multiplied by time.delta time, so it all happens at a fixed consistent rate. So yeah, every frame our velocity will get set to 0, and then we'll have -15 added to our y velocity, and then we will add that to our movement. So we go back here to our vector 3 velocity before we put it into the character controller. And then afterwards, after we've done the movement speed, we can do plus vector3.up, because the direction we're working with is on the y-axis, and then multiply that 1 by our vertical velocity. Velocity y. Now we should have gravity. So we've calculated, we've checked if we're touching the ground. If we are touching the ground, the velocity gets set to 0. Then what we do is we put a little bit of a down velocity just to make sure the player is stuck to the ground and not slightly floating, because that can happen if you do it the other way around. Now we hit play. We see I walk over here to the ramp, I go up, and I come down. So now we have a fully controllable player in our little game. And nearly done with this, with everything. That's pretty much the bulk of it all finished at this point. The only thing we have left to do is make a little UI for our health bar, maybe like a crosshair for we can shoot. Oh, we also need to make a way for us to actually shoot our weapon. So next week we actually have something to defend ourselves from the zombies. So let's go back into our code. Oh no, wait, I need to make some new stuff. Back into our code first, because remember we've cluttered up our update method, so we're going to just copy that out. Then we're going to do is private void and then movement. And there we go. And now we can just throw that back into there. Oh, not like that. Movement. Cool. So you can see the style that I'm going for here, where you've got the update, which is happening every single frame, and then it immediately branches off into the different areas, and we can hide these to keep everything nice, not cluttered, easy to read, easy to follow. So we have all our variables, our public variables, our global variables in one place, all of our code in one place. It's all nice and organized, everything's clean and good. Go back into Unity, just let it recompile. Okay. Let's get to work on just a little bit of code to make our gun actually shoot. So the gun is related to the player. The zombies aren't going to be able to use a gun as far as the current design plan. So we can put the script for the gun inside the player file. So we're going to create a new script, and we're going to do gun controller. Okay. Let me just get that out for you. Gun controller. The gun controller, we're not going to need most of that. We are going to be working with the Unity engine, so we need model behavior. So first what we're going to do is we need a reference to our... if you guys want to look up some more information on this, go look up raycasting, because that's how we're going to be doing it. That's how in pretty much all games actually work with combat, like in terms of weapons. How it works is it essentially fires a laser pointer from one position to another, and then if it hits something, it considers that as you shooting, your bullet hitting that guy. It doesn't actually simulate the bullet. To do like full bullet simulation is quite intense on a computer. Just look up Supreme Commander series if you want to see what that can do to your computer. Anyway, so we need a reference to our camera. Now, because our camera is tagged with the main tag, that means Unity, the Unity engine can find it very easily, and we don't actually need to make any kind of references. We don't need to clutter the editor up or anything. So we can make a private camera object, and we can call it cam. Now we can do void start, and then inside void start we gain a reference to it. So cam equals camera dot main. And now Unity knows that because I said the main camera, and this camera is tagged as a main camera, I now have a reference essentially without having to like drag anything around, link anything, look for any IDs, nothing like that. Unity does all that for you. Okay, let's actually get to work on shooting it. So we can do a private void update. And now we needed to detect if a the mouse button has been fired. And we could two ways of doing it. We could do the usual way, so we can do if input.get button down. Get mouse button down. We can do mouse button down, and we can say 0. Mouse button down 0 is left mouse button. Button 1 is right. Button 2 is middle mouse. Because remember, it's working off of an array, and arrays are always length minus 1. But there is also an easier way you can do it, because what if the user later down the line wants to change what the shoot button is? What if they want to make it like spacebar or something? So instead, what we're going to do is use Unity's input manager. And what we're going to do is we're going to do get button down, because we only want it to happen once. The difference between down and get button is get button will detect a held button. Get button down will only trigger once when the button is actually pressed. And then the opposite of get button down is get button up, which will trigger when you release the button. And what we're going to do is fire 1. Now, fire 1 is your left mouse button, but if we want to change it, we don't want to have to go in the code and find all the references to mouse button 0. But if we just go to the Unity input manager, we can simply just change it right there, really easy, really quickly. Okay, and now that we've got it, so this if statement will be true every time we fire, every time we press mouse 1. Next, we're going to be using our Raycast. Remember that laser pointer I was telling you about earlier? Raycast, and we're going to do a Raycast Hit, and we're just going to call it Hit. Why do we call it Hit? I don't know, everybody on YouTube calls it Hit. But no, because like the only information that's being stored in this hit object is the data from what that laser pointer has actually hit. So like the transform information, the transform information mainly. And once you have that, pretty much you can access 90% of whatever that object has on it in Unity. It also stores the length, the distance between the launching point and the contact point, the time it takes and stuff like that, and stores a lot of information. But we're only going to use it for one thing. So we need to do physics. It's another physics-based thing. It's okay to do physics-based. It's okay to do this physics-based on an update because it's not really too important, because what you would normally do is have a fire rate. Can you change with this line of code or after this? So if in terms of like style of shooting, if you're referring to between a raycast, so like just instantaneous, like you click the button and if your crosshair is over your enemy, it hits them, to it actually simulating the bullet presses, slightly different. What you would do is you would swap out the raycast for it actually spawning a bullet object at your gun barrel and then basically giving it a punch with apply force, with the apply force function, and then see if that has a physical contact. But it's really difficult when you start approaching higher speeds. I can maybe show you an example of that in week 4. Maybe in week 4 I can maybe change it around, show you like maybe if you wanted to make like a bullet hell, actually like one of those bullet hells, that would work perfectly like that. You would just change the raycast for spawning objects and pushing them away from the character essentially. So we're going to do physics. Once again, like raycast physics, the only real one that you can safely use inside of a regular update, essentially. So physics.raycast, we need the starting point. So we have our camera .transform.position, so the position of the camera in the world, our main camera that we got a reference to earlier, and then we need like a destination for it to go to, so it can figure out the direction it needs to fire the laser beam off in direction. So really easy. We can just do cam.transform.forward. And then that's just straight out from the camera. With the whole animation. Gunshot. What you can, shooting the whole animation of the gunshot, or only when it hits the target. If you wanted to display an animation or like a hit when it hits the target, Raycast will be instantaneous. Like the exact same frame it does this physics check, it'll be instantaneous. So that'll apply information back as soon as it hits the target. If you want it to, more like if you guys know the revolver in Counter-Strike Global Offensive, where it plays the animation first, you would have that animation in Unity, and you can set a trigger on that animation, which calls a function in your script, like a call, almost like a callback, similar to like the hierarchy system I showed you in the beginning. Similar to like this. So like these are callbacks essentially. So you can see user callbacks, internal functions. In fact, let me make that bigger for the stream. So you would have animation. So here's our physics-based, event-based, game logic. So it happens somewhere around the game logic area. Here, on animation, animator move. So this one here is when you would want to play the bullet shot itself, like after the animation of the gun firing. Okay, so just to continue with that, so we have our for it. Now we want information out of this, so we can do out hit. And what that's going to do is that's going to take all the data that this physics.raycast has created, package it into our hit variable, and return it. It's a really easy way of doing it. And then we need to check when this happens. So we can just wrap the whole thing inside of an if statement, because it will return a true or false if it's actually hit something, or if it's just continued on forever and it's died. Because we can add more to this. We can add more to this physics.raycast. Like we can add a length. So you can see there's like 9 of 16. Right now we're working with variant 9. Yes, so you can do, so the animation can play. There can be a keyframe in the animation, or like a specific timestamp essentially in the animation, which would trigger a function inside your code which would actually like simulate the shot. You can totally do that. Or, really easy way of doing it, if you know the length of the animation, just add a delay. You can add a delay on casting the raycast. So you can see like there's like dozens of different variants of like physics.raycast we can do, but we're just working with a simpler one for now. So once that's done, we're just going to end it there with this. We don't really want to get into physical combat. That's for next week. So we can do debug.log, and then we can do hit.transform.name. And what this will do is this will just print to the console. We hit, it'll print the name of the object that we hit, and the name is the name of the object in the hierarchy. And then that's the gun controller done. That's literally that simple. So we can take the gun controller, we make sure we have the player selected, click and drag the gun controller script here. We have no dependencies on it. We can literally, we don't have to attach anything to it. It finds all the information it needs. It's literally a drag and drop. We click play. And now I can, if I shoot the floor, you can see we hit plane. If I go over here to this cube, you can see I hit cube 11. And then if I go over here, I can click on this. Oh, right, remember I disabled the click interaction. If I click here, we can see it's cube 11. So we are successfully finding what we're shooting. And like I said, once you have the ability to find the transform, you can find anything about the object you're looking at in Unity. Cool, so that's that done. Lastly, let's just get some nice UI to help just make things a bit more visual, and then we can test maybe some damage to the player, and then we should be done. Okay, UI creation in Unity. Sounds complicated, once again. Easy to begin with. In my opinion, it's a little bit harder than everything else, but it's generally on the easier side. So what we can do, actually, we won't have an event system. What we can do, if we want to create a UI, we can right-click in our hierarchy, go down to UI, and let's create a little crosshair so we know where we're shooting, okay? So we can come down to UI, click image, and you can see it's made this massive thing here in the scene view. But if we look in the game view, it's just this tiny little square down here. Because this big square here is on this kind of size frame. So I currently have my resolution set to 1920 by 1080 for the game. So you can click here, I can change it. So I can do free aspect ratio. So now it changes dynamically with my game view. Or I can change it to, I believe there's like some mobile phone aspects. I can change it to 4K if I want to. And now you can see the little cube is even smaller. But I develop most of my games on 1080, and then also like this is how you could do like testing for like sizes in your games, so, like different resolution options. And this is also why a lot of games don't really have a free aspect ratio, which have really complicated UIs. It's a lot more prevalent on games which have more in-world UIs. Like Dead Space is a good example. That has a free aspect ratio, if I remember correctly. Because there's no UI, it's all on you. Like all your HUD is on you essentially. Anyway, so we want to scroll out to that. Really easy tip to help working with canvases. So you can see it's create a canvas, image, and event system. Easy tip to work with canvases. Turn your game to 2D, and now you can just zoom out. It's a lot easier to navigate, and you can see this white box here. This is the game window. This is what my UI sees. So if I change it to free aspect, you can see as I move this, you can see the box resizes. Yes, Unity can do 4K. You'll need the models and everything like that to do 4K, but the Unity engine can do 4K, yeah. Yep, it's in the base Unity. Yep, it's perfectly available in the base version of Unity as well. Because you can edit your own custom aspect ratios. Like I can edit my own. So like here's a 10 by 10 aspect ratio of our game, and then this is us going around playing our game in 1950s. You know, just back on what's it called? Trailwind or something like that. So you can totally add your own. Like you can add your own like insane aspect ratios. So even if it isn't in base Unity, you can add it quite easily. Okay, so we have this. Now, anchor systems. So we have our image in our canvas, and the image has to be inside our canvas for it to work. If it's not inside your canvas, that's your main problem. If you are having a problem with anything like that, check it if it's in your canvas. So we go over here. Our inspector has changed slightly. The main thing, I'm just going to breeze over a lot of this right now. We can discuss it more later. We're going to click the middle and center part here. This is our anchor points and our positioning for our image. So you can see if I move it here, now this crosshair is moved up here. This is now the anchor point for that image. So now if I rotate, global, local, never mind. The anchor point, oh, right, yeah, anchor point. Sorry, nothing to do with rotation, that's my bad. That is to do with how the canvas moves. It'll now move relative to this anchor point here. So what we're going to do is we're going to set that back to the middle. Now this one, what we're going to do is we're going to have it be our crosshair. So crosshairs tend to work better when they're in the middle of the screen. So with this center open, with this anchor preset, we can hold shift, which allows us to also move to the anchor point. So we can click. Never mind. Oh, right, this is expand. This is expanding the anchor point itself, so just ignore that. This is something I don't really work with too much, but shift allows us to expand and contract the anchor point. We can hold Alt. Now this is what will move it. So you can see the gray box is moved. Now if I click. So if I shift Alt, and then you can move it to different areas. So I can move it left, right, up, down, center. I can also expand it to the full size. I can just do left, up, right, middle, you know. All really easy, and then I can have it recentered. Cool. Little bit on the big side for a crosshair. So what we can do is we can go here, and the width, we're just going to set to 1010 on the width. Really small. Now we can't see it, so we're going to make it black. And there you go. There's a little tiny dot for our crosshair. And then with this image, you can overlay your own stuff onto it. So if you have like an image of a crosshair that you've drawn or anything, you can just simply add it here as a sprite. No problem at all. Really easy. Just change it from black, otherwise you can't see it. So we got the crosshair. Let's go ahead and rename this to cross. Cool. Oh, by the way, that little trick there, I talked about it last session. If you click on something, you quickly want to go to it, press F, it'll focus on it. So we focus back on the canvas. Let's make our health bar real quick. So we're going to create an empty game object. We're going to do this health bar. just to keep everything centralized and easy to follow. This health bar, we want to anchor it to the top of our screen, so no matter how our vertical aspect ratio changes of our game, actually I can demonstrate this if I change it to free aspect. You can see no matter how the vertical aspect changes, that crosshair here always stays on the top, whereas the middle one is always staying in the middle because that's where I set it to. So we got our health bar, right click, we're going to create a new image, so UI image. And now you can see our new image has been set immediately to the top, which is good. We want to just drag that down ever so slightly just to make it a little bit nicer to look at. We can go and resize it on the X plane just to make it a little bit wider, smaller, just make it look a little nicer. And then what we can do is we can set this to like a gray, make it a little bit transparent. Image. So this is the background of the health bar, if you can think about it like that. So health bar back. Now we need the front, so this will be the red part of the health bar. So we can right click back on the health bar itself, not the back of the health bar. UI image. This is a new one, so this is health bar front. And then what we can do, you can see how it's there. We want it to be the same, but we don't want to have to adjust the sizes. You know, like we could go in and it's like, okay, maybe it's like this big, maybe this big. Or no, you know, it's really awkward to get it to the same place. So easiest way to do it, click the health bar front, put it in the health bar back, and then open up our center again. Control Shift Alt click on it. Shift Alt click. Could have done that. Why you no work? Oh, right. Helps if you actually put it inside the health bar itself. Shift Alt click, and then that should have. Oh, I love it when it doesn't work. Whoops! I made one mistake. It is working. I messed up. The health bar back, the border, you can see this little white box here, this little white box. This is what it's trying to match it to. Not the actual image size itself. So if I just go through here, reset you like that. And then the health bar itself. There we go. Oh, come on. Oh, what did I do wrong? Okay, we go back. Delete. Canvas. New UI image. Health bar back. Health bar back we set. There we go. Now it's working. I don't know why it wasn't earlier. Expand it across the top, shrink it down a little bit, because we don't want it so big. Cool. Now what we do is we create, again, our health bar front. Health bar front, this we set to the size. There we go, now it works. Okay. I don't, this is why I don't really like working with UI. It never works. So we want to like just add a little border. So we can go up here to the top. So we can set this to 10. And we can set our left, top, right, bottom. Now we have a little tiny border. Actually, that's a little bit hard for you to see. So maybe like a border of 50 might be better for the stream. So we have a little border just to keep everything looking a little bit nicer. And then we can set this to our red for our health bar. Cool, all good. Oh, I also forgot the health bar controller, but it's fine. So player health bar is going to be unique to the player itself. Zombies will not have a health bar at the moment. Yeah, oof, indeed. So we are going to do player UI controller. Just make a new script, player UI controller. Open that up. open up. Where is it? Yes. Cool. Player UI controller. Not really going to need any of that at the moment. Now, we need to import a package. So we're going to come up here above our public class to just underneath the Unity engine itself, and we're going to do using, and then we're going to do Unity engine again. Yep, Unity engine.ui, because we're going to need access to the image object. And the standard Unity engine does not have the image built in. Cool. So now what we need is we need a serialized field, because we need a way of accessing this health bar image. It's going to be a little bit harder to find it, but once again, it still fits with our theme, because this script has no reason to exist if we don't have a health bar in the game. So we can cheat a little bit here. Serialized field, and then we want a private image, and then health bar. Health bar, that's our reference. Another serialized field, we need access to a player controller. Come on. Oh, because I'm typing the wrong thing. Private player controller. Player. It's okay to do it this way around. Yeah, well, because if we don't have a health bar, this code will not exist. So it's okay for us to grab a reference to the player, because if we take the player out of this, it doesn't affect anything else. For a controller, how different will your current controls from mouse would be? So, like I said earlier, the cool thing about how Unity is working is to do controller input. I don't have a controller connected at the moment, so I can't show you. But if we go to the project settings, project settings, and we have horizontal and vertical, this is for keyboard input, but we also have, let me just find it, horizontal, oh no, sorry. Here, it's already built in. Horizontal and vertical, you can see down here, these types, axes, is it? Horizontal, vertical, yeah, so joystick axes, here, it's already built in. So the x-axis on a joystick. So because, and this is the cool thing, because we're using we're working with the input manager, we're not going around the input manager trying to design our own thing. It's already all there, so I can connect a controller to it, and this should work perfectly fine. I mean, you might have to tweak some movement systems and stuff like that, like the movement speed and things, but other than that, it should be fine. Should be like no code change at all. At least that's every programmer's dream is not having to change any of the code. Okay, player UI controller. We have the reference to the player. We have the reference to the health bar. Then what we're going to do is we are going to just simply do. Oh, cool. We actually managed to make it to the time where I get to talk about actions. I actually get to talk about actions now, which is probably the coolest thing and the hardest and most annoying thing to wrap your head around, at least for me. Some other people get it better than me. So we have these, so in Unity, sorry, not even in Unity, these are built in. This is what your system has for C#. You have actions and functions. Functions we won't talk about now because actions are like functions. Anyway, it would be really cool in our code right now if whenever we took damage as a player, our health bar would update. Now, the way we could do that in the health bar script is if we go into the health bar, we do a private void update function, and then in this update function, we keep asking the player every frame, what's your health, what's your health, what's your health, what's your health? And then we just set the health bar to that value. Wouldn't it be really cool if this script could just be told that the player has taken damage without it needing to know? And then also, wouldn't it be cool if other systems in our program could also know that the player has taken damage without having to check with the main player code itself? And that way as well, if our player controller suddenly disappears, the health bar script and the other things that also want to know this information won't break because they just won't ever hear the trigger signal that they're listening for. And this is what actions, functions, they're like compressed delegates essentially at the end of the day, like compressed events and delegates. But really, just think of them as actions for now. It's much easier to think about. And the way that I like to think about how they actually work is you have a radio station, and this radio station is broadcasting on a certain frequency. It doesn't care who is listening, because the radio station will still broadcast even if nobody is listening or if 1,000 people are listening. And all of a sudden, if that radio station goes away, those listeners are still there. They're just listening to a dead radio station. And that's how I like to think of how actions work. So we can actually implement that really easily into our health bar script and demonstrate it. If we go into our stats, okay, and this is where this take damage script will come into play. We can make a new function. This has to be public because other things need to know about it. Called action. Oh no, wait! First, you need to go up here, up to the top, using system. And then what we can do is a public action. So now we have an action, and then as well with action, you can even pass it a type, 2 types, 3 types. You can pass it multiple types as well. So you can specify input values. So not only does this radio station tell you or just tell you something has happened, like the news, but it can also like broadcast like addresses to people's houses or restaurants and stuff like that. And those addresses come from the restaurants themselves, in a way. But for now, we're just going to use the base action. So it's just radio station broadcasting to people. So we do, and this is like an event. So on. So we use the word on because something has to happen for this to work. On damage taken. Okay. So this will be called when some damage is taken. And then when we take damage, when this take damage script happens, we can do on damage. On damage taken dot invoke, which means broadcast, hey, I've taken damage. Now there's a small problem with this, little caveat, where you have to make sure that if you are invoking it, you can get a null reference error I think it's an index out of bounds, either one of those two, but you can get an error like this if nothing is listening. So if nobody is listening and you try to invoke, like you try to start that radio station, it's not going to work. It's not going to work. It still can work if nobody's listening. We have to check for it. And the coolest thing we can do in C is, instead of doing if on damage taken dot length is great, instead of doing that whole like if length is greater than 0 kind of thing, we can just simply put a question mark. It's that easy, because if it's null, that question mark will not let the compiler continue past it. So if on damage taken is null, it will not run the invoke part, and that's really cool, don't you think? Anyway, let's go back to the player UI now. Oh, let's save that. Let's go back to the player UI now, and now whenever that player takes damage, it'll tell anybody who's listening. Once again, it doesn't care if anybody's listening, but it'll still scream it at the top of its lungs. So we can go back to the player UI controller. Now, what we have to do in order to start listening, to tune into this radio frequency, is we have to do. I'm just going to start using some of the unenabled. These are specific things. If you download the basic Visual Studio with the Unity package, because Visual Studio comes with a dedicated Unity package you can install, you can actually like fast type a few things. So you can do on disable, and then it automatically completes for you. Nice. Yeah, I couldn't get code to work in a way that I liked. The auto completion was really slow, and it just was an absolute pain. Anyway, so on enable and on disable. And how these work, if we go back to our order of operation, execution order, we have awake. On enable is the next thing that happens. And then on disable happens somewhere down on disable. It's the second last thing to happen apart from on destroyed. And what that is referring to, if I come over to my script and I click the player, okay? If I focus back on the player, let's also change it back 3D. Sorry, I forgot to mention at the top. Just below scene view, next to where it says shaded, there's a little 2D button. That's how you change between 2D and 3D. You just click it. So if I select my player, and then I come up to the right here on the inspector, there's a little tick box. If I untick it, he goes away. It says display 1, no camera reading, no camera rendering. That is me disabling the player. And then when I click it again, it enables the player. And I can do that in code live. Like if I want, like we'll see it next week because that's how I'm gonna make the spawning with the zombies really efficient. So if we go back to our code, on disable, on enable, the reason why you want to do this is you can have problems because you have references to disabled components, which essentially are null, that are trying to be accessed, and that can cause things to break. So on enabled, you start listening. So we have to do player dot player stats dot on damage taken, and then to subscribe something, actually at the moment we have nothing to subscribe to it. So the listener to the radio station isn't doing anything when it hears the signal. So let's quickly go make that. Let's just comment this out so everything works. So we do private void on player damage taken, run this script. Okay? And now we can come back here. On damage taken plus equals, because we're adding it to the on damage taken action list essentially. We can subscribe on player damage taken, and we call it. We use it like a variable. We don't put. See, if I try to call it like a function, I'm essentially trying to add a function call into this list, and it doesn't work. You can do that with functions though, but on actions you do it this way. So you treat it like a variable because essentially it's a reference to it. So now what Player UI Controller will do is when it hears the radio station say, hey, the player's taken damage, it knows, okay, I have to now run this function. And it until then, it sits dormant, it does nothing. All it does is it just waits. And it's using like virtually no memory, and it's beautiful. So once we do that, we have to update the health bar. So we do health bar dot. Oh, right. We have to get that set up. Sorry. Let's first finish this. So we do that on enabled, and on disabled. When it is disabled, we have to remove it from the list so we don't get any null reference exceptions. Okay, let's go back. Important thing about our health bar. So for our health bar, this is the only time I'm going to break my rule about no external, about not using anything external. Because the built-in Unity sprites aren't really that good, in my opinion, because they don't really deform well, essentially. So if we go to, yep, there it is. If we go here, we can see we have no sprites, okay? So if we go to materials, this is in relation to the player. We want to, instead of creating a new material, I'm going to just drag this little image that I made earlier called health bar, and all it is it's just a white square that is, well, it says 64 by 64, but essentially it's 48 by 48, and you need to make sure that all the images you use, in order for the Unity's compression to work, it needs to be a multiple of 4. That's like the only key problem with that, is it needs to be a multiple of 4. But other than that, 2 seconds in Paint, just make 48 by 48, or just it can be something like a 4 by 4. Because I'll show you in a minute. If I go to the health bar, the red part, okay, this is what I want. I want the health bar to like deplete, to slide to the left as I take damage. So I can use one of Unity's built-in sprites. So if I try to use this, and then I changed from sliced to filled in the image type, you can see it gets really distorted. It looks like a squashed button almost. But we can now change the fill amount, and you can see it's like a timer. We don't want that. We want, instead of the rotational 360, we can see the fill method. We can do horizontal, and now we have our health bar going back and forth. And then you can change it on the style. It can go to the left, it can go to the right, however you want. But you can see it's not that great. So this is the only time I'm breaking my rule of just for this course of like no extra assets. So just to quickly talk you through in case you want to do this, we click on our health bar material that we want. We want to set this to a sprite, so you can see texture type is default. So we come down here, we click it, we click sprite, 2D, and UI. Then it's going to ask for a size. It's not really too important, but the size of my image is 48. So we're going to click that. Now you can see it's reset. And you can see it's RGB compression, DXT1, all that good. Don't need to worry about it. Ignore it for now. And then what we can do is come back to our health bar front in the source image. Now we can find our health bar, and you can see now it's returned back to a square. This image can be whatever you want. I'm just putting it as a square for simplicity. But now you can see as we drag it, we have what looks like our traditional health bar. Cool. Let's also get a reference to this. So on our health bar, we're going to go to our player script folder, player UI controller. We're going to drag it onto the health bar back component in our object in a hierarchy. We need a reference to the health bar itself. So that's the health bar front goes to health bar. And then player, the player container goes to the player. And then that's that all set up. So let's just save, because I don't think I've done that this entire time. And let's finish this off. So on player damage taken, we've got health bar dot fill amount, which is this, which is what this value is here. This fill amount value here, because that's coming from image. Fill amount equals, and then we're just going to do simple math, just player stats dot the current health divided by player stats dot max health. So this will get us our like 50 divided by 10 is 0.5 values, because you can see like these are like between 0 and 1 here. But really good. Let's go in and implement just a way of damaging ourselves so we can just very quickly test this out. So what we're going to do is we're going to go into our player controller itself. Player controller. Since this is just for testing, it's okay for us to use the update. It's not really permanent code. And then we're just going to use something really simple. So just if input.get mouse button down 0. So this will only work on the left click on the mouse, not on anything else, but this is just for testing, so it's fine. Player stats dot take damage, and we're going to take 10 damage every time we click. Okay, and then if we go back here, fingers crossed that this all works. I've had 2 problems this session so far, and we have no reference exception. Excellent. What this is referring to, and I really hate it, you see how it's referring to the player UI controller? We have essentially a small problem. We are working on the player controller, we're working with awake. And awake is happening up here. Awake is the first thing that happens, and on enable happens second. So what is happening is we have essentially something like a race condition, if anybody knows, and I'm going to say like a horrible word, but if anybody knows multi-threading, we have something akin to a race condition. We've got 2 different programs. One is triggering on enabled, one is triggering on awake. Actually, would that work? Can I just throw in a standard awake? But if that fixes it, I'm going to be so annoyed, because that was 3 hours to solve that problem. Nope. Okay, good. So all we're just simply going to do is have it here, and then not here. Normally you would have it here, and I'll come up with some elegant solution for next week and I'll share it with you guys, but this is just a simple fix. This needs to be start. Just to explain in more detail what happened, because we have the player stats being created on awake, Unfortunately, the other script is asking for the player's stat information on enabled before the player's stats have been created. Getting all the cores to run the program. Yeah, something like that, where essentially you've got two different scripts that are both running at the same time, and the problem is one is asking for information that the other one hasn't created yet. And the annoying part about this problem is the other one creates it literally half a second later. Like, not even half a second later, like half a frame later or something like that, it creates it. It's like so annoying. But this, so I'll come up with some way of better solving this problem, but for now, just because this isn't really good, because the problem is on start, I'm being tuned into the radio station, and then if I'm disabled when the code is running, I'm now not listening to the radio station. But if I'm re-enabled, all of a sudden I'm not listening for the radio station anymore because I haven't been told to listen to the radio station. But this should fix this problem. Yep, you can see problem's fixed because now I'm forcing them, and if I click, my health bar goes down. Now my health bar is going down. There's no code in this health bar script that's checking. It's only being told that something has happened. So you can see my health bar is going down, and that's all good. So that's pretty much all I'm going to cover in this session today. It actually ran on, I think I'm just perfectly on time, which is good. Any final questions from you guys in chat? But just to recap everything we've done, the player creation, camera movement, player movement, shooting is set up. We just need something to shoot next week. The player health bar is working. We've created a little crosshair just to help the player aim. And then maybe in week 4, I'm thinking of creating just an ammo system, but we're only really going to be able to play around with that once we get the shooting in place. But yeah, so just any questions from you guys in chat? I get the feeling that I actually missed one thing. I did. Does all this cool Unity features also include the Unreal Engine? Unreal Engine works very similar. The only problem, they have their own way of doing it, of doing these things, and they're using C++, I believe. Either C++ or C. I think it's C++. So the code will be different. Thanks, Akillan. I'm glad you enjoyed it. The one thing I did miss, however, so because it's a minor change, it's not really going to be that big of a problem, but you see how my cursor is just always here and I can accidentally click off the screen and now my game doesn't work. 2 lines of code to fix that. We go back to the player controller. In Awake, once we've created the stuff, we can do cursor, cursor dot lock state equals, this is changed because Unity used to do it a different way, but this is the new way of doing it. So cursor lock mode is locked. And in fact, we can do confined even as well. So that confines it to the screen. So confined means, yeah, I can't leave the screen. So if my mouse comes over here, I can't leave the screen, or here, you see I can't leave the screen. Locked will lock it to the middle. So locked is better actually for a first-person shooter. And then we'll still see the cursor, so we just want to hide that as well. So we want cursor again dot visible equals false. And now the cursor will be locked in the middle of the screen and hidden. And now you can see I can move around, I can click, my health is going down, and we're all good. And then if I want to get my cursor back, I just hit escape. And now I can move around in the world. Come back here, the cursor gets relocked and re-hidden. And all good. And you see the gravity's working. But yeah, I'll be hanging around for another just 5 minutes until 5 past. Or maybe that's too short. I'll hang around until 10 past in case anybody has any other questions. I know the stream delay is a little bad. I'll try to also fix that for next week. Just in case there's any questions, if anybody wants anything. I might regret saying it, but maybe some fiddling around with the code lab. I don't want to say live coding because that's going to end horribly. I'll actually. Oh shoot! I shouldn't have done that. I could have posted that in chat. Okay. I should have done that. Unity order of operations. So in case anybody is interested, this is the link to the order of operations for Unity. And if anybody wants to follow up on mono behavior, the mono behavior and Unity engine manual itself, there you go. Okay. As long as the lag is comfortable for you guys. And if you have any questions throughout the week, you're more than welcome to leave it in the comments section below. Or if you have any ideas for something that you would like specifically to see me implement on week 4, because at the moment that's just a live session, and then maybe like just a little, maybe adding some like particle effects to like maybe when the zombies die and stuff like that, and then that'll be built on the action system that we have. So when the zombie dies itself, it'll trigger a separate action, and then that'll allow that'll allow other components to know, so that the particle system will know. Because I'm interested to see if I can get away with having one particle system controller instead of having dozens of, like, not one particle system controller, but one script to manage all the particle systems. Because another thing you can do with these action events is you can have a separate script. You can actually have like your own script, which is just the user inputs and other yeah, photogrammetry models. Unity has a lot of really good high-res models, but not by default. Like with everything, the Unity asset store is immense, massive, and you can find almost anything you're looking for. It's very easy. In fact, something that I would encourage people to do if they want to learn a little bit more about how these bigger systems work is there's a lot of free assets on the Unity asset store, like small things, like individual components. Like you'll have one which is just like an inventory system, or one which is like a player movement system. Download those free assets and import them into a Unity, and then take them apart, because they're they're not like encrypted or anything, so you can fully like rip them apart and stuff. And in terms of the models, you can find really high res models, and models work across everything. Like a model that'll work in Unreal is also a model that'll work in Unity perfectly fine. They moved the asset store. I just have to. Let me open it up on a different monitor. They've changed where the asset store is in the. Yeah, so this is what you can do quite easily if you just Google Unity Asset Store, top free assets, and then you can see, so like you got Bolt, which is visual sculpting. So this is more like visual scripting. That's more like essentially they took Scratch and they put it in Unity, which is amazing and scary. But yeah, so you can see there's like high-res models for like trees, like free island connection and stuff like that. There's also RPG character mechanics. This is one I have. And like I really enjoy it. So you can see like this is just, you can download this for free, and it's all fully integrated, fully working. But download it. Don't download just this and make a game out of it, because you'll learn nothing. Download something like this, take it apart, look at like the individual like lines of code and what they actually do, try to implement and then change it. And that's like truly the best way you can actually like come to grips with how Unity works. Like also here you've got a starter asset pack and stuff. Here's the villages. And like some of these games that appear on Steam, they post their assets to the Unity Asset Store as well. And these are just the free ones. Like they've got lots of paid assets. You also have game sounds and stuff. Okay. But I think that's everything that we had to cover for this. I'll hang around and chat a little bit longer. Just in case anybody has any last minute questions, I'll respond to you then. But anyway, I hope you guys enjoyed and have a great day.